Hi guys, today we'll be presenting on the analysis of road maintenance in San Diego. So for our research topic, we'll be examining how San Diego's inadequate road maintenance impacts individuals and communities and how that correlates with San Diego public sentiment and resident satisfaction. Our reasoning for this topic stems from our personal experience as UCSD students who have experienced damaged roads and most commonly seen through potholes and vehicle damage. So our project aims to understand road maintenance and weather patterns in San Diego. And we hypothesize that infrastructure damage repair reports will increase during rainy weather, that there is a disproportionate impact of this trend on economically disadvantaged neighborhoods in San Diego, and that there's a positive correlation of increased resident living satisfaction and positive sentiment towards the city government.
So we had two data sets we were working with. The first was obtained from the National Weather Service San Diego forecast records. It contains the average inches of rain that San Diego receives for each month from 2017 to 2024. And the second data set we're working with was obtained from the City of San Diego Get It Done app, in which citizens can input pothole repair requests. It contains a large number of categorical and numerical data, as well as a description of the pothole. So for data cleaning, we had to change a lot of the values to be able to actually analyze and work with. So we changed the date columns to PD date time objects, and the rainfall, we removed missing values, mainly future dates we don't have data for. And in the pothole dataset, we also removed missing values as well as duplicates, and we identified which variables we wanted to work with and dropped the irrelevant ones.
For exploratory data analysis for the rainfall data, we looked at the rainfall across time. The graph on the left shows the distribution in rainfall in San Diego across different months of the year, with months like December, January, and February, March having the largest average rainfall and also more variance. The graph on the left shows the monthly rainfall across years. We can see that the rainfall each year has generally a similar trend of increasing around the later parts of the year. Then for the pothole repair request, we looked at the monthly requests across the year, with the number of requests increasing around November and December and decreasing afterwards. The graph on the left shows the communities with the highest request count, with Claremont Mesa and Mira Mesa having the highest number. Similarly, we also looked at the median number of days it takes for these communities to respond to requests, with communities like Balboa Park and Uptown having only a few days, and Rancho Encantada and Los Penasquitos Canyon having a higher average or median days.
From the pothole dataset, we did a word frequency distribution and sentiment analysis on the description submitted by citizens to get an understanding of the overall sentiment towards road maintenance in San Diego. On the left, as expected, we see that potholes, lanes, streets, and other road-related words are the most frequent in the dataset. On the right, we see the distribution of the overall compound sentiment scores, and we see that most of them are centered around 0, meaning that they're overwhelmingly neutral with some negative tendencies. Next, we did a comparative sentiment analysis based on communities with more or less requests. Here we see the community with the most amount of requests, Claremont Mesa, has an average compound sentiment score of negative 0.068, and we see that community with a less amount of requests, Serra Mesa, has an average compound sentiment score of negative 0.03, which is less negative than Claremont Mesa. From this, we can assume that the areas with more pothole requests had a slightly more negative sentiment score. Next, we did a comparative sentiment analysis based on communities with more or less income. We see that a community with high income, La Jolla, has an average compound sentiment score of negative 0.16, and one with lower income, San Ysidro, has a score of negative 0.02, which is much less negative than La Jolla. La Jolla also has a larger amount of requests and a much more negative sentiment score than San Ysidro. From this comparison, we can hypothesize that residents of higher income areas are more likely to submit more complaints and have a more negative sentiment than residents of lower income areas.
Finally, we ran a multiple linear regression for the month, year, and rainfall and its relationship with the number of repair requests, with an R-squared scored of 0.731, indicates that these variables are strong predictors for the number of requests. Similarly, each of the variables has low p-values, indicating that they are significant.
So after analyzing all the data, we found a significant linear relationship between time of year, amount of rainfall, and the number of pothole repair requests. We found that communities of higher income are likely to file report requests with stronger negative sentiments, and we do have to consider the limitations of the sentiment analysis from only the public description. But overall, our project sheds light on how road maintenance is impacted and related to weather and public sentiment.